Hello everyone. This video will show how to solve a given system of equation using the inverse matrix method. So in this problem, we're given these two system of equations and we're supposed to determine the values of x and y that works for these two equations. The first step that we need to do is to write the matrix equation or the system of linear equation in matrix form. So this equation that we have right here tells us that matrix A times matrix X is equal to matrix B. Now let's define what matrix A, X, and B are. We remember that matrix A consists of elements that are the coefficient of this equation that we have here. So we get a 4, 5, and 1, -6. And matrix X consists of the two variables that we're looking for. So that is X and Y. And matrix B consists of the constants. In this problem, we're looking for the values of X and Y, which is matrix X. So we can go ahead and rearrange this given equation right here so that we will have matrix X by itself. So that we can have X by itself on one side. Again, we got that from here. So that we can have X by itself on one side, we are going to multiply both sides by the inverse of A. If we multiply inverse of A and A, they cancel out. So then we go ahead and say that the leftover is X equals the inverse of A times matrix B. Looking at the equation that we got right here, we have a B. So this is our matrix B right here. And the X matrix, which consists of X and Y, is the one that we're looking for. So we need to figure out what is the inverse of A, which is this matrix right here. I'm going to go ahead and write the general formula for the inverse of a matrix. So this is the general formula for the inverse of a matrix. That is 1 over the determinant of matrix A times the adjugate of matrix A. Since our matrix A right here is a 2 by 2 matrix, so we're going to have a specific equation that works only for a 2 by 2 matrix. So if we let our matrix A, which is a 2 by 2 matrix, consist of elements A, B, C, and D, we can go ahead and say that the determinant of matrix A is, so the determinant of a 2 by 2 matrix A would be the product of the two diagonals, so that is A times D minus the product of the anti-diagonal, which is B times C. Now, the adjugate matrix is, we will flip the position of A and D, and we will switch the sign of B and C. Now, let's plug this equation into the general equation for the inverse of a matrix. So this is the specific equation to find for the inverse of a 2 by 2 matrix. Again, this works only for a 2 by 2 matrix. So in this matrix A that we have right here, our A is 4, our B is 5, our C is 1, and our D is -6. So I'm going to go ahead and write those values down here. So what we do next is we plug in these values of A, B, C, and D into this equation to solve for its inverse. So this is the inverse of matrix A. So from here, we can go ahead and use this equation up here to solve for X and Y. So we go ahead and plug in the values. Our matrix X is XY. Our inverse matrix of A is the one that we got right here. And our B matrix is up here. So we got a 2 by 2 matrix and we have a 2 by 1 matrix. Now notice that these two numbers are the same, so we can go ahead and say that this is possible, which means we can multiply these two together, and the resulting matrix is a 2 by 1 matrix. So let's go ahead and multiply these two matrices together. So we're going to multiply 6 over 29 times -3. So that is -18 over 29. And we're going to multiply 5 over 29 times -8. And that is -40 over 29. And we're going to have 1 over 29 times -3 is -3 over 29. And we also have -4 over 29 times -8 is +32 over 29. So that from here, we go ahead and simplify this. So -18 plus -40 is -58. They both have the same denominator. So that is -58 over 29. And we have a -3 plus 32 is 29 over 29. So we go ahead and simplify this. -58 over 29 is -2. 29 over 29 is 1. This tells us that our x is -2 and our y is +1. So that is how we solve a system of linear equation using the inverse matrix method.